You're walking through tall grass barefoot and you feel it before you see it. Two sharp points, a burning sting. You look down, a snake is already gone. Your heart is now pumping poison through your own body, faster with every panicked breath. No hospital, no antivenom, no phone. Just you, the venom, and whatever your ancestors figured out a very long time ago. For most of human history, a snakebite wasn't an inconvenience. It was one of the leading causes of death in the natural world. And yet, humans survived it again and again across every continent where venomous snakes exist. Not by luck, by knowledge. Some of it brilliant, some of it deadly wrong. Let's start with the moment the fear became a science. In ancient Egypt, snake bites were common enough that physicians wrote an entire medical manual about them. It's called the Brooklyn Papyrus, dating back to roughly 450 BCE, and it's one of the oldest surviving medical texts in human history. Inside it, Egyptian doctors listed different snake species by name, described their bite symptoms in precise detail, and even predicted which bites were survivable and which were not. This wasn't superstition, this was pattern recognition, built from watching hundreds of victims die and hundreds more survive. Around the same era, in ancient India, physicians were doing something even more advanced. The Sushruta Samhita, a Sanskrit medical text compiled roughly 2,600 years ago, classified venomous snakes by the type of damage their venom caused: blood that wouldn't clot, paralysis, tissue death. That distinction mattered enormously, because different venoms required completely different responses, and getting it wrong could kill you faster than the bite itself. Here's where it gets dangerous. For centuries, the common instinct almost everywhere was the same: cut the wound open and suck the venom out. It feels logical, it feels heroic, it's also almost useless and often deadly. Modern toxicology has confirmed that venom spreads through the lymphatic system within minutes, far faster than sucking could ever remove it. Cutting the wound just added a second injury: bleeding, infection, tissue damage on top of the first. So why did it survive as folk wisdom for thousands of years? Because the people who tried it and lived told the story. The venom dose, not the suction, was usually what decided the outcome. But here's what nobody talks about. Some ancient treatments weren't folklore at all. They were real pharmacology, discovered centuries before chemistry existed. In the Amazon, indigenous communities have long used specific plants, including species in the genus Mycania, applied directly to snakebite wounds. In 2016, researchers publishing in the Journal of Ethnopharmacology tested these plants in laboratory conditions and found measurable venom-neutralizing compounds inside them. Knowledge assumed to be superstition turned out to be functional chemistry passed down through oral tradition for generations, with no lab required to discover it. Meanwhile, across parts of Africa and Asia, another strategy emerged: not medical, but ecological. Communities learned to recognize which animals hunted venomous snakes and live near them deliberately. The mongoose is the most famous example, a small, fast predator with a genetic mutation in its nervous system that makes it remarkably resistant to cobra venom. Ancient communities in India didn't understand receptor mutations, but they understood that a village with mongooses had fewer deadly encounters, so they protected the mongoose, and the mongoose in turn protected them. That's not myth, that's applied ecology centuries before the word existed. Now here's the part that still saves lives today. In 1895, French scientist Albert Calmette, working at the Institut Pasteur, developed the first true antivenom by injecting horses with small amounts of venom and harvesting the antibodies their blood produced. It sounds almost identical to a much older idea. For thousands of years before Calmette, some cultures practiced controlled, repeated exposure to small amounts of venom, believing it built resistance over time. Modern medicine confirms the logical sound, even if the ancient method was dangerously imprecise. They were reaching for immunity centuries before anyone could explain what an antibody was. Sit with that for a second. Long before microscopes, before antivenom, before germ theory, humans were already testing, failing, surviving, and passing down a working science of venom, written in symptoms instead of formulas, passed down in stories instead of textbooks. But it was science, earned the hardest way possible. Go back to that moment in the grass. The sting, the fear, the venom already moving. Your ancestor in that exact same moment, thousands of years ago, had no antivenom either. What they had was everything you just heard: observation, plants, animals, trial, and the willingness to survive long enough to pass the knowledge on. Most of what they tried didn't work, but enough of it did. Enough that the knowledge kept moving forward, bite after bite, generation after generation, until it became the antivenom sitting in a hospital refrigerator right now. You will probably never be bitten by a venomous snake, but somewhere in your instinct, the way your whole body freezes at the sight of something coiled in the grass, that's not irrational fear. That's ancient memory still working exactly the way it was built to. So the next time something moves in the grass near your feet, don't feel foolish for jumping back. That reflex is older than language, and it's the reason you're here to feel it at all.